Hello, and welcome to this video lecture. In this video, we will talk about the properties of powers and roots. Let us start with the property of size of powers. The size of the nth power of a number depends on whether the positive value of the number is larger or smaller than 1. Depending on where the number is from 1, the direction of the inequality sign would change. This concept frequently appears on the GMAT. If x is greater than 1, then the number increases as the power n increases. X is less than x squared, less than x cubed, less than x to the power of 4, and so on. If 0 is less than x is less than 1, then the number decreases as the power n increases. X is greater than x squared, is greater than x cubed, is greater than x to the power of 4, is greater than, and so on. For examples, 3 is less than 3 squared, is less than 3 cubed, is less than 3 to the power of 4, is less than, and so on, and 0.1 is greater than 0.1 squared, is greater than 0.1 cubed, is greater than 0.1 to the power of 4, is greater than, and so on. 2 is less than 2 to the power of 2, is less than 2 to the power of 3, is less than 2 to the power of 4, is less than, and so on. And 0.9 is greater than 0.9 squared, is greater than 0.9 cubed, is greater than 0.9 to the power of 4, is greater than, and so on. Let us first talk about the first property of square root and cube root. To multiply the nth root of two numbers, we multiply the two numbers and then take the nth root of the product. So, square root of a times square root of b equals to square root of whole a times b, and cube root of a times cube root of b equals to cube root of whole a times b. For examples, square root of 2 times square root of 3 equals square root of whole 2 times 3 equals square root of 6. Cube root of 2 times cube root of 3 equals cube root of whole 2 times 5 equals cube root of 10. Let us talk about the second property of square root and cubed root. To divide the nth root of a number by the same nth root of another number, we divide the two numbers and then take the nth root of the quotient. So, square root of a over square root of b equals to square root of whole a over b, where b is not equal to 0, and cube root of a over cube root of b equals to cube root of whole a over b, where b is not equal to 0. For examples, square root of 6 over square root of 3 equals square root of whole 6 over 3 equals square root of whole 2 times 3 whole over 3 equals square root of 2. Cube root of 10 whole over cube root of 2 equals cube root of whole 10 over 2 equals cube root of whole 5 times 2 whole over 2 equals cube root of 5. Let us talk about the third property of square root and cube root. If the square root of a number, n, is squared, it is equal to the absolute value of n. So, square of square root of n equals to square root of n squared, which is equal to modulus of n. For examples, square of square root of 3 equals to square root of 3 times square root of 3 is equal to modulus of 3, that is equal to 3. Square of square root of 2 equals modulus 2 equals 2. Square of square root of negative 2 is equal to modulus of negative 2, which is equal to 2. Let us talk about the fourth property of square root and cube root. This property is also known as the distributive property. If two roots are in the form of a product of a root and a real coefficient, then the addition or subtraction of the roots is the product of the root and the sum or difference of the coefficients. So a times square root of b plus c times square root of b is equal to a plus c whole times square root of b, where b is greater than or equal to 0. Also, a times cube root of b plus c times cube root of b is equal to a plus c whole times cube root of b. For example, 2 times square root of 5 plus 3 times square root of 5 is equal to 2 plus 3 whole times square root of 5, which is equal to 5 times square root of 5. 2 times the cube root of 4 plus 5 times the cube root of 4 equals 2 plus 5 whole times the cubed root of 4 equals 7 times the cube root of 4. Let us talk about the fifth property of square root and cube root. This property states that the nth root of the sum or difference of two numbers cannot be distributed over the numbers. That is, we cannot distribute the values within a root if the values are being added or subtracted. So, square root of whole a plus b is not equal to square root of a plus square root of b. For examples, square root of whole 25 minus 16 is not equal to square root of 25 minus square root of 16. Since square root of whole 25 minus 16 is square root of 9, which is equal to 3, and square root of 25 minus square root of 16 is 5 minus 4, which is equal to 1. Square root of whole 16 plus 9 is not equal to square root of 16 plus square root of 9. Since square root of whole 16 plus 9 is square root of 25, which is equal to 5, and square root of 16 plus square root of 9 is 4 plus 3, which is equal to 7. Let us talk about the sixth property of square root and cube root. An even exponent under the same even root will result in an absolute value of the number, while an odd power under the same old root will result in the number itself. So, square root of a squared times b is equal to modulus of a times square root of b, and cube root of a cubed times b is equal to a times cube root of b. For example, square root of negative 3 squared times 5 is equal to modulus negative 3 times square root of 5 equals 3 times the square root of 5. And cubed root of negative 3 cubed times 2 equals negative 3 times the cube root of 2 equals negative 3 times the cubed root of 2. Square root of 2 squared times 3 equals modulus 2 times square root of 3 equals 2 times the square root of 3. And cubed root of 2 cubed times 3 equals 2 times cubed root of 3. These are the 6 properties of square roots and cubed roots. These concepts frequently appear on the GMAT, so make sure you know them well.